All right. So, additional quick little housekeeping just to put everyone's mind at ease. I know in the session guide this said this was sponsored or hosted by Trend Micro. It is. This is not at all a sales pitch. I do not mention Trend Micro or Trend Micro product in this. This is purely educational. I'm here to teach you about security in the AWS Cloud. If you want to talk about Trend Micro, we're in the expo hall right in the middle. You can go talk to the Canadian team. They're fantastic, eager to answer any of your questions. This session is all about how security works in the AWS Cloud and how you can transition into that sort of mentality. It's very different than what you're used to today. So I know this is early, so let me get this started with a little audience participation because I am unapologetic in making sure that you guys are awake. How many of you guys are with federal government? Okay, so as expected, the majority. Provincial? One. I love it. The one. Me, just me. It's all good. I won't pick on provincial. Municipal? All right, one more as well. I love it. Okay, so I will try to reference all levels. It's applicable to everybody, but obviously with the majority of federal in the room, we're going to be focusing on that mentality, but I know that trickles down as well. So with that, let me give you a couple numbers that are a little scary. 21%. 21% of Canadian businesses replied in StatsCan's latest survey in 2017 that they'd been affected by cybercrime. That number is steadily increasing. Every time StatsCan does a survey, this number keeps going up. Whether it's ransomware, whether it's a denial of service, whether it's something else, Canadian businesses are impacted by cybercrime. Here's a worse number. This number has not really changed in the last decade. 170 days is currently the average time an attacker stays on our networks. That's not a winning number. That means attackers get access on our networks and sit there for the better part of a year waiting, doing whatever they want, harvesting information, right? So cybersecurity is obviously a major challenge. It's a major problem. And I think a lot of it stems from the traditional workflow. So we're going to go back to basic cybersecurity mentality and understand how we do or why we do what we do today. So we start with services. Okay, we have something that we know our customers want, right? And we're going to offer that service over the internet. Now this is really old school, the original use of cloud, the internet itself, not a cloud like AWS. Okay, so we've got services, we're offering them to our customers over the internet. We also have employees that are going to access these services to update them, to maintain them, maybe to use them as well. But on the internet, there's also bad people, right? Bad people doing bad things, and there's a lot of problems. It's not a clean environment by any stretch of the imagination. So what do? Well, from a cybersecurity mentality, we're going to put something in between us and the bad stuff. Right? That makes total sense. We've got bad stuff out on the internet. We're going to shove controls between our services and the outside world, and we're probably going to shove some controls between our services and our employees as well, just in case, because there are some challenges, though somewhat exaggerated, over insider threats. So this is totally makes sense. No one's going to fault anybody for building out like this. And we've got our threats identified. We've got controls between the good stuff, which is our services, and our threats. And we want to make sure that the good communication still happens so that legitimate customers can get our services and that legitimate employee activity can continue. This is how we got our traditional perimeter, right? Everybody's familiar with perimeter design. We all live with this. This is how we deal with our services today. Makes 100% sense. It's how IT was delivered. It's a strong wall around what we value. The problem with walls, though, is that people go around them. And in this day and age, people go around them very, very easily. So, you know, whether they're over them, under them, or through them, we see 92% of malware is deployed via phishing. Now, I know there's probably some security folks in the audience who are like, well, it's OK, we run phishing awareness campaigns. How effective do you think those are? They're not very effective. There was a study done by NYU this year where they found the absolute best, I'm cherry picking this number, it's a positive number, the best phishing awareness campaigns increased the response, so users identified malicious links 2.7% more of the time. So basically ineffective, right? So we need to look for a technological solution here. But when we look at security, how it's built up this way, right? Security is traditionally very controlling. It's mine. I like to put my arms around it and I'll protect the server. It's very manual. Everything's extremely manually oriented, and that means it's very, very slow. But it doesn't have to be that way, right? We don't have to settle for that, even though we have, which is amazing, frankly, as a cybersecurity professional, that we've gotten away with it for so long, right? We know attackers are automated, yet we're responding manually. So I'll give you a quote from Steve Schmidt. He's the CISO of AWS. This was from Tuesday Night Live last year at AWS reInvent. Great quote. If you have people sitting in a room looking at screens to make your security detections actionable, you're probably too late, right? And for anybody who works in a security operations center, you know the truth of this statement, right? When you get a detection from 8 hours ago and you go, well, an attacker got it 8 hours ago, I guess we'll go clean it up. 8 hours is an eternity, right? For reference, and Angela had mentioned all these slides will be available on the AWS SlideShare. This is from Tuesday Night Live at reInvent last year. It's available on YouTube right now. Fantastic whole event. This is probably the best 7 minutes of modern security talk you will ever hear. This is Steve Schmidt's section from last year, and he talks about how AWS runs their own internal security in a modernized, highly automated way. It is absolutely wonderful, well worth your time to invest the 7 minutes there. Because at the end of the day, when you look at all of this stuff and how we're building, how we can build, how we can move forward, whether you know it or not, right now you're paying a huge cost. Because the vast majority of time, and I'll speak directly so the two people who are not federal can have a smile, hopefully, because maybe it's a little better. You know, in a federal government project, security is a gate, right? You get it at a certain point during the project management phase and right before you go live again. Whether you know it or not, that's costing you double what it should for security. In time, in effort, in effectiveness of solution, it's costing you double. If you just take one step earlier in the stage before things are getting out into production, you can greatly reduce your security costs. In fact, if you keep going earlier and earlier and create a collaborative security environment, so instead of just security being the people who stamp things at the end or from the security folks in the room, when you're handed something and they say this needs to go live on Monday, you're like, wow, what a great ton of options I have if I've got 72 hours to make sure this thing is secure. If we move earlier and earlier, it gets cheaper and cheaper because that 2x cost between stage and run actually is a 30x cost between when you're planning it. Right? So if you can work with your development teams or work with your teams who are taking off-the-shelf software to build security into your deployment earlier, you are going to save a massive amount of time and a massive amount of money. Okay? And I'm not here to preach a new cultural development. I know that it's very, very difficult, especially the way that most government departments are set up. There is isolated silos between all of these things, apparently for a reason, but it does not implement into effective security. But if you can break down those silos, if you can integrate security into your applications and your operations teams, not only are you going to see that cost reduce, but you're going to be far more effective. We've seen, now this chart is from the State of DevOps 2018 report, and they surveyed 30,000 organizations around the world, and they broke them into cohorts. And you'll notice this elite cohort in the green column, it was about 7% of these organizations had managed to get teams that were cross-functional, working well together. So security folks were talking to operational folks, they were talking to developers, they were talking to the architects throughout the process, not just one-time consultations. And they were able to get down to multiple deployments per day and be able to queue a deployment within an hour. So if you think in your head, a typical emergency patch situation, even though we all plan for it, it ends up being a scramble. You got to go convince people that this is important enough to skip your normal process. The risk of deploying this patch and breaking things is worth it because what this patch covers is an easy remote exploit. So if you look at Apache Struts 2 over the last year, there's been 3 one-line remote code execution vulnerabilities. Literally one line of code from the attacker jumps past everything and into your systems. Those are the patches where you rightfully freak out and want to deploy quickly. But right now, our normal process is going to break your quality assurance. What this report proves is that if you build into this cross-functional mentality, if you break down the barriers and adopt this workflow for building in modern and effective ways, you don't have to break your quality assurance. You don't have to break your normal process. Your normal process is fast enough to handle those emergency situations. And that's an absolutely massive security win. This is what we've been pushing for years as security folks, to be able to get things done quickly and effectively without taking additional risks. We're here to cut down risk, not to take more risks. So it's something to think about. And I know culture change is extremely difficult. It's the hardest thing out there. But it's something to set your sights on to start pushing for because there are huge security wins. So don't freak out if the application guys come in and say, hey, we want to go DevOps. They might not know what it means entirely. But for you, what it means is deploying smaller pieces of functionality into production, which reduces your risk. and doing it faster, which also reduces your risk. Another great quote from Amazon. This is from Dr. Vogels, the CTO of Amazon.com and AWS. Security is everyone's job, right? We need to act like security is everyone's job. And we're going to walk through some stuff today that shows you how you can get some great, easy automation wins in your deployment, how you can move forward and modernize your security and start responding automatically instead of by hand. So one thing that I will give you as a tip when you're talking to other teams within your organization, a lot of the time in security, we tend to define security as the CIA triad, not the cool CIA, the other CIA. And we talk about integrity, availability, confidentiality, all this kind of stuff. And we have technical definitions for cybersecurity and information security. I will give you a far simpler one that will resonate far more with the people you're dealing with. Our goal in cybersecurity is very simple: to make sure that your systems, whatever those systems are, work as intended and only as intended. That's it. It's nice and simple. Now, it's a different definition than stopping hackers or bad guys. This definition requires teamwork. It requires us getting out there and integrating and breaking down those silos and working in cross-functional teams. So, another quick survey, because I notice everyone's kind of dropping off and I feel like wheeling the coffee cart around. How many folks are familiar with the shared responsibility model? Show of hands. Okay, not too bad. A couple, maybe about 5% of the room. So the shared responsibility model is very well named. It explains how security and operations work in the AWS Cloud. Okay, and it's very simple. You're actually using the shared responsibility model today in your departments, in your organizations, whether you know it or not. Okay, so we'll walk through it and show you very simply. So we start with an on-premises environment. You're sharing the responsibility amongst yourselves. You have teams that work across these 6 areas, very rough areas, that need some sort of care and feeding every day. So we start at the bottom, we look at physical, right? Is your data center, is it safe? Is it built on a good foundation? Infrastructure, things like heating and cooling, network, large upscale network connectivity, into virtualization, the operating system, applications, data, right? 6 rough areas that need work every day. Now, right now, in your current environment, you probably have different teams for each of these. Right? You'll have a team that handles the annoying and boring stuff like leases for your data centers, right? Or maybe you've pushed that out to another department into shared services, but somebody somewhere is handling the physical stuff. They're handling the infrastructure. They're making sure you've got backup generators. Someone somewhere is probably running a VMware layer, right? There are teams that are responsible for this, and they all eventually roll up to somebody. Okay, so you've taken all these responsibilities in your organization. Shockingly, the shared responsibility model is about sharing each of these responsibilities out with somebody else. So when we start to move into the AWS Cloud, right off the bat with infrastructure level services, we lose half of the direct responsibility. Now, for the security folks in the rooms, you probably just went, oh, I don't like losing half of everything. Trust me, it's a big win. It's half the work that you don't have to do. This is what you're paying somebody like AWS to do for you. So they're going to take care of physical infrastructure and virtualization layer. A great example of an infrastructure level service is something like EC2. Right? You make a call to the EC2 API, and you get an operating system and a server running. You get full access to that. You are responsible for everything from there on out on that instance. If you want to set your admin password to password, go ahead. Please don't. Go ahead. There's a pro tip for you. Do not set your admin passwords to password. But if you wanted to, it's your responsibility, right? It's up to you to make sure you fulfill the rest of that agreement, the rest of that arrangement. Another good example here is your security group, right? You can set your security group, which is the tiny little firewall that wraps around your EC2 instance. You can set that to be open to the world on any port you want. Again, pro tip, don't do that. Just don't ever try to do that unless you're running a honeypot. And even then, it looks kind of suspicious. But if you try to do something like that, which is fully within your responsibilities, the AWS Cloud, the management console, will prompt you no fewer than 3 times to tell you that this might not be a good idea. But every single time you can say, no, I want to do it, no, I want to do it, no, I want to do it, because it's up to you. It's your responsibility. Okay? As you move higher up the stack, go to something like a platform service, you're responsible for the application and the data. Okay, so you can think of something like EKS or ECS, the container service, right? You're no longer running the host OS. You have access to it, but it's managed, and you can run your applications on top of it. So one more layer that you're pushing down to somebody else, right? I don't know about you, but I like doing less work. It's a big win for me when I can get somebody else to do work for me. Of course, my teammate in the back is just chuckling, going, yeah, this guy doesn't do any work. So when you move all the way to the abstract, to the SaaS level services, you're only managing your data, right? You're managing the data that you put in. So think of something like Amazon S3. You ask for a bucket, you shove files into the bucket. You need to choose what data you put in there, and then you need to tweak the configurations and the options that they provide you to customize the service. But you're responsible for the data. You never see an S3 application. You don't see the OS that's running under S3. You certainly don't know the data center that it's in, right? That's the advantage. So from a business perspective, you want to be pushing as far right as possible all the time, because it's less work you have to do. It's more value you're getting from your cloud provider. From a security perspective, you want the same thing. The reason being is you're delegating more and more of the security responsibility out to somebody, to AWS, who does it at a world-class level. So if you want to visualize the perimeter sort of on top of this, you've got the thickest perimeter on premises because you own all of it. As you move over, it starts to shrink even more until you get almost no perimeter that you're responsible for. All of this stuff still exists, right? There's still firewalls, there's still network bandwidth monitoring, there's still all the stuff that you're used to doing today all on your own, but you're delegating it more and more off to AWS. Now, I know what you're thinking, well, I'm not going to trust them blindly, and you shouldn't. This is why you can go to aws.amazon.com/compliance, and you'll see they're in a logo competition with all the other cloud providers to see who can get the most obscure logos on the compliance page. All the big ones you're looking for are there, and you can get their attestations to their certification. So you can verify that they are doing the work that they say they're doing. Okay, so that's the shared responsibility model. Does that make sense to everybody? Kind of, almost. I got a couple nods. Does that make sense to everybody? Awesome. See, I knew I should have brought coffee, but I will just keep bugging you until I'm like human coffee. So the best way to think about AWS as you're starting to deploy into AWS is that it is a pile of Lego, or generic building brick for the copyright lawyers on YouTube. It is a pile of bricks that you can build whatever you want from. Right? You can build crazy, amazing things, or you can replicate what you're used to. Please do not replicate what you're used to, because that's like taking a Ferrari to school to drop off your kids. It's a waste of power and elegance. There's so much more that you can do. You can build in a modern and dynamic way. You can automate the vast majority of things you're used to doing by hand. And of course, as you're taking your first steps into AWS, that can be pretty intimidating. So there's a thing called the Well Architected Framework from AWS. This is a living set of documents. If you just search for AWS Well Architected, it's prominently on their page. And it's set up from the understanding and the lessons learned, sometimes good, sometimes bad, from years and years of AWS ProServe, of the AWS solutions engineers, and some key partners contributing back in of how to build effectively within the AWS Cloud. And it breaks down to a number of pillars. So it starts with operational excellence, cost optimization, reliability, performance efficiency, and security. And the idea behind the well-architected framework is that you can't have everything. It'd be nice, but you can't have everything. So the well-architected framework walks you through how to make intelligent trade-offs for your situation. So sometimes you might pay more for more reliability or for more performance. Sometimes it's not appropriate, so you're going to pay less, then you're going to increase your automation for operational excellence. It's about balancing these, right? It's a fantastic set of documents. It's a relatively quick read. Where we're going to start, we're going to dive in a little bit into the security pillar. These are all areas that we're familiar with, right? Identity access, infrastructure protection, incident response. This is nothing new. This is not groundbreaking. It's just helping you translate these concepts into the AWS Cloud. Specifically, when you dive into these areas, there's a few principles around the pillar that they want to enforce, right? So implementing strong identity, that's always a given. Applying security at all layers. We talked about the advantage of building security in early. Automation, protecting data at rest and in transit. I love this one, keeping people away from data. That doesn't just mean bad guys, that means everybody, keeping everybody away from data. AWS is strong proponent of automating systems as much as possible. You should never have to have somebody log into a production instance to make tweaks. There should be an automated system that pushes these things out. So keeping all people away from data, and then preparing for security events, right? Nothing revolutionary here. But again, strong security foundation. This will help you bridge from things like the TBS guidance, like ITSG 31 and 33 and all the rest of them, into a modern world. We're going to focus on a few of them in the rest of this talk, because we're going to dive into how to do some basic automations. So we're going to look at traceability, we're going to look at automation, and we're going to look at keeping people away from data. And I'm going to give you a basic scenario. Okay? So let's say we've got a server. Now, a server in the AWS world is an EC2 instance. Okay, this is where we've asked for an EC2 instance, we've gotten the keys to the castle, whether it's Windows or Linux, and we're responsible for securing that OS, the apps, and the data. It always lives within a security group. Okay, there always has a security group attached to an EC2 instance. This defines what traffic's allowed in and out. And for our sake, because we've read the Well-Architected Framework, we're going to put our EC2 instance into an auto-scaling group. This is a concept where, as various metrics that we define, they will add or take away more instances to our application. So if we're running a thing like a web server and the traffic starts to spike, we can add more web servers automatically. AWS takes care of it for us. And then as that traffic goes back down again, those servers are shut down. So the application will automatically scale up and down based on the criteria that we say. So this is how we've wrapped our instance. And then because we know we're responsible for the operating system, the applications, and the data, we're also going to put an additional security tool on there, whether that comes from an AWS partner or for open source security tool. We know we need more than just the basic OS protections, right? We need more than Linux provides out of the gate. We need more than Windows provides out of the gate. So we're going to add a tool on top of that. So we've got our little server. And let's say we have malware dropped onto it. So if it's a web application and we allow file uploads, somebody dropped malware as part of the file upload. What we're going to have is our security tool, whether that's from a partner or open source, is going to send a message saying, hey, I found malware. Whether I quarantined it or not, it's going to give us a message saying, hey, I found malware, I took care of it, but you should be aware of it. That sends what's called an SNS message, so a simple notification service message, to a topic, which is basically just a channel to send those messages. And we're going to use a Lambda function, which is a little bit of code that executes serverlessly in the AWS Cloud to respond to that message. And in this case, what we're going to do is we're going to take away any risk here. Now, in a normal scenario, if you're sitting in your department right now and in your SOC and you get a notice that there was malware and it was quarantined on a user's system, what are you going to do? You're going to evaluate the risk. You're going to see what strain it was. Is it an indicator of other attack and just part of it got caught? There's a whole bunch of questions that pop up that you don't have definitive answers to. So you may ignore it. Right? You may file it as triage, it's not worth responding to. You may increase your overall monitoring, or you may blow away that system and give the user a new one. It really depends on who it is, the data they're open to, but there's a lot of decisions there, right? And you may be taking on aggregate risk. You may say, we're going to leave it because I think the endpoint tool took care of it. But here we don't have to. We don't have to take that risk at all, and we don't actually even have to be involved. So what we're going to have our Lambda function do is actually lock down that security group. So we're going to lock down that security group so that server no longer takes traffic. If a user tries to call into our web server, that server will not respond. But because we've locked it down, what happens is our scaling group spins up a new server. Automatically, nobody involved. So now we have a brand new, fresh server that's never been touched by malware, whether that malware was handled or not. We've reduced any residual risk. And yes, you can tweak your function to make sure that the new server is up before the old one gets crashed, depending on your application, so that you're not denying service to other users. But we've removed any residual risk. And that way we can send another, or the auto-scaling will send out another message that tells us that, hey, it's scaled up and everything's fine, and we know we're OK. We've handled this malware incident with no human interaction. Absolutely, completely automated. Total cost to respond is under a penny. No security people involved. You can come back at the end of the day and go, oh, yeah, that was handled great. That was handled great. Don't have to worry about it. Finally, you've got a basic automation loop that's responding to attackers who are automated. Best case scenario, that malware was a one-off. You don't have to worry about it. It's been handled, right? Your system's clean. You've got a brand new system, never been impacted. Worst case scenario, you've got a persistent attacker who continues to hack on the door. They're caught in this loop, right? As they gain a foothold, that foothold is destroyed and a new system is brought up. So you may have user access issues because you're constantly cycling, but at least the attacker is no longer gaining a foothold until a security analyst can come in and actually apply human intelligence to it, right? This is a basic automation loop. It's a very tip of the iceberg of what is available and possible in the AWS Cloud, it takes about 8 lines of code, right? 8 lines of code, under a penny per loop. You can't ask for much more, right? Compared to today, where you get a firewall alert, a malware alert, it processes through your SOC, probably goes through 1 or 2 people. They have to make a decision of whether to accept the residual risk or not. They probably don't have enough information to make that decision, but they're going to do, sort of shoot from the hip, best idea. And then they have to manually remediate anything. Purely automated loop, out of the box. All you need is something on the instance to indicate that there was a security event. Does that seem interesting? Seem cool? I love it, just utter dead silence. Everyone's like, I take it because maybe you've never thought of security in that way. And in fact, that's how I'm going to take it, so nobody say anything different. I'm going to assume that's not how you've thought about security. You haven't thought about security as programmatic, as accessible, right? As automatable. We've tried for a long time to make it like that, but it's never really been possible. Remember back to my earlier comment that we're dealing with a ton of generic building bricks that we can build into whatever we want? And there's such a strong focus on automation, that's a massive, massive win for security. We just need to kind of flip that switch in our head and go, wait a minute, security is like almost every other operation. It's like software quality. We can start automating these things so we don't have to worry about it anymore. So there's a lot more tools in the toolbox, and that's what we're going to talk about right now. We're going to talk about the AWS Security Services set. So when you log into the AWS Management Console, has anyone actually logged? How many people have logged into the AWS Management Console? Okay, good. I assumed that. It was good that I checked. So the vast majority have. When you are, I will politely say, assaulted by this list of services. It is growing all the time. AWS reInvent is at the end of November. This is going to get even bigger, and that's a great thing. We're getting new functionality, new services all the time. There is actually a category for security, identity, and compliance. This is the current list of services. We are not going to talk about these services, and the reason being is AWS Cognito, single sign-on, and directory services are all about user authentication. It's a pretty straightforward, understandable concept, and most people in this room already have something like Microsoft Active Directory, where you're using that to authenticate your users. So we can save some time not by not addressing those. They're pretty straightforward. If you do need something to make sure your users are who you think they are, one of those 3 services will do it for you. So that being said, here's how I lay out the AWS Security Services. So these are my categories just based on experience. We've got in the top left, we've got protected stores. So we've got something sensitive that we want to save somewhere. In the bottom, we've got build tools. So certificate manager and inspector are tools that helped us build securely. And then on the right side, we've got runtime protection, and then runtime protection at the AWS edge. So for those of you, I know a lot of people are new to the AWS Cloud, the edge might be a different concept. Everybody's heard of regions? Yes? Hands? Yeah, right on. See, you're going to get your workout. So at some point, switch to the other hand, just to make sure you're evening out. So AWS regions, pretty straightforward. We have one region in Canada. Within that region, there are multiple availability zones, right? There's also the concept of the AWS edge. The AWS edge is 120 plus points of presence around the world. And this is where services like Route 53, which is the DNS, CloudFront, which is the content delivery network, as well as AWS WAF and AWS Shield, as well as Lambda and Edge are delivered from, right? So they're not full regions. They're places that are geographically dispersed to speed up performance. Okay, that's the edge. And the edge keeps growing at a ridiculous rate, so I'm sure by the time you're watching this on YouTube, 120 is the old number, and we're up to 1 billion, right? So the edge is a set of services as well, and we're going to talk about that. There's also some security services that are really important. So you see AWS IAM, that's the identity and access management. That's the core security service. But also another core services are CloudWatch, which is events and alerts and metrics. AWS CloudTrail, which is a cryptographically signed cloud or trail, audit trail of events in the AWS API. So whether you're using a command line tool, software development kit, or the web browser, the vast majority, it's like 99.8 or something around those lines, of AWS calls are logged into CloudTrail. So you can go back and look and see who made what call when. And AWS Config, which is a compliance service. So all of these together are stuff that you're going to be using quite often from a security perspective. We're going to walk through how each of them connect together over the next little bit here, okay? Because some of them are named really well, and some of them are named not so well. And you can follow with me here. So we're going to start up in the top corner. Cloud HSM is where you store your security encryption keys. Okay, it's a hardware security module. Cloud HSM is the new version of the service that launched about 18 months ago. If you have encryption keys, they should be sitting in here. It's really simple, really straightforward. On the same note, AWS KMS is short for Key Management Service. You will not find it in that big list. For some reason, it's hidden under IAM, the Identity and Access Management, but it lets you create policy for your encryption keys. So if you want to give a certain server an encryption key on Tuesdays between 9 and 5, you can do that through KMS. So if you've got encryption keys in use, KMS should be defining the policies to manage them. Any guesses as to what AWS Secrets Manager stores? No? Yes, thank you. It's one of the very well-named services. I guarantee an engineer named this, and marketing did not get involved, which is a good thing for us because it's clear as day. It stores secrets. Now, there's another service called the AWS Parameter Store that a lot of people say, well, why don't I put my sensitive stuff in Parameter Store? You absolutely could if you want to, but a great way to separate those data sets and to create separation of duties is to use Secrets Manager for anything that's sensitive. So API keys, any sort of backend authentication that you need. Secrets Manager is there because it also has some ability to help rotate those secrets, right? Very handy. Amazon Macy, which is not yet available in the Canadian region, but is deployed in US West and US East, helps you identify and categorize sensitive data sitting in an S3 storage bucket, okay? AWS WAF, it's a web application firewall sitting at the edge, so it can stop a lot of basic web-based attacks, things like SQL injection, cross-site scripting attacks. Some basic things like that can get filtered out at the edge before they ever come into your instances. One of my favorites, AWS Shield. Is anyone using AWS Shield? Hands? Oh, one hand, OK. Anyone have an AWS account where you've deployed anything? Awesome. You guys are all also using AWS Shield. It's a service you never really have to notice. It is deployed on all accounts by default. AWS runs it. It's distributed denial of service attack protection. You can get an advanced version where they'll help you in the middle of an attack. But it's one of those things that makes perfect sense. As AWS has this massive global network, they are doing a lot of the DDoS protection for us because they've got the scale, and they see it before it ever hits our accounts, right? So you can get an advanced version that helps you create rules on the fly in the middle of an attack if you need it. Amazon Guard Duty does continuous threat detection for your Amazon account, for your AWS account. Very handy. Inspector looks at security assessments on your EC2 instances, and we'll touch on this one a little bit more in a minute. Again, fantastically named Certificate Manager. If you need TLS or SSL certificates, you can get them through the API in Certificate Manager, which is great. You'll notice with 3 dedicated encryption services, Cloud HSM, KMS, Certificate Manager, there is no excuse not to be encrypting your traffic at rest or in transit within the cloud, because any performance hits are not your problem. When you ask for a certain level of performance, you will get it, encrypted or not. AWS absorbs the hit, right? So all the previous arguments about complicated performance challenges, they're all gone because there's somebody else's problem. Another reason why the shared responsibility model makes sense. Now we come to my absolute favorite security service, AWS Artifact. Hands down, my absolute favorite. The reason being, does anyone know what Artifact is? No? You shouldn't. There's no reason you should. AWS Artifact is literally a single-page web application that is a series of buttons. That's all it is. You click a button, you get a document. The reason is why it's my favorite is because it solves a very real need around compliance. If you need AWS's compliance attestation around ISO 27001, which is a lot of really long words to put you to sleep, you click a button, you get it. Anytime you're dealing with any sort of compliance framework, if you need to report your compliance or you're looking for AWS's level of compliance, Artifact is that service. Okay? Your previous standard used to be you had to open a help ticket to get that document. Now you can just click a button. I laugh because they tried to make it sound cool with Artifact and gave it a funky little floating diamond icon and its own whole service level. It's literally just a bunch of documents. But those documents are absolutely critical when it comes to any sort of compliance scenario. So we're going to look at these 4 services together, and I'm going to explain a couple quick little automation loops around them. Because we talked about how to do that simple Lambda automation with EC2. That's a basic stepping stone. Now we know there's a whole bunch of great services from AWS that do various things, right, in our security posture. So let's see how we can connect those together. But first, let's make sure we understand exactly how these work. For Amazon Inspector, so if we start left to right, Inspector is looking for problems on our EC2 instances, right? It's looking for problems on our servers. When we look at Guard Duty, it's looking for problems in our AWS account. and then Macy's looking for problems in our S3 buckets, and WAF is actually stopping problems on the edge. So you notice there's a bit of a difference in the verbiage there, right? We've got 3 services that are detect only, and then WAF is actually a preventative service. So if it sees an attack and has a rule, it'll stop it. You can turn that off and ask it just to tell you. Why would you ever turn it off? It can stop it, let it stop it. So we're going to look at how we can connect these 4 services to automate some of our security burden. Okay? To do that, though, I'm going to do a quick little deep dive. We've got time. I'll do a quick little deep dive into how do each of these things work as a service themselves and the value that they provide. So we'll start with Inspector. We have our EC2 instance, and we know we're responsible for the security of the operating system and the applications and the data on top of that instance. That's how the shared responsibility model works. So Inspector is actually an agent that sits on our EC2 instances. If you're using one of the AWS managed AMIs, so like Amazon Linux or the Amazon Windows, it's already sitting there for any supported OS. And what Inspector Agent will do is it'll run an assessment. Now this assessment can be as short as 15 minutes or up to 24 hours. The longer it runs, the more it sees what's going on that instance and reports back that behavior. So within a 15-minute run, it'll come back and say, hey, you're running Nginx as a web server. You have version 1.2.3. Version 1.2.4 is out. And there's a known vulnerability against that version. You should probably update. Here's the risk. Here's our suggested mitigation. So an assessment run, you ask for an assessment run to be run. It generates a finding. And then in that finding, you get things like the rules package it was associated with. So if it was particular to a compliance regime, something like PCI, it'll tell you that. The severity, the timestamp. If there's a CVE, which is a common vulnerability notification for or label for it, you'll get that, as well as some mitigation recommendations. That's Inspector. Pretty straightforward, but you need to tell it to run, right? Or you need to schedule it to run. It's not just running in the background, unlike something like Amazon Guard Duty. Guard Duty runs looking at VPC flow logs, which if you have them enabled on your virtual private cloud, will tell you who spoke to whom, when, and for how long. So just basic flow information, not detailed flow information. Your CloudTrail logs, which record all of your AWS API calls and who made them, as well as you can define specific IP lists and say this is known good, these are known bad IPs. Let me know if anything's going on this. Guard Duty operates continuously. So once it's set up and enabled, it's just always on looking for problems in your AWS account. When it finds something, shock of shocks, it gives you a finding. And then in that finding, we get some critical information like affected resource. It will give us the Amazon resource name, the ARN, for what it found, and some IOC details, so some details of what it found and specifics, and then give us that timestamp as well. That's important information, right? It gives us that finding. Macy also operates continuously. It's looking at S3 buckets and S3 objects. It's actually looking in those objects and buckets. So if you do enable it on your buckets on US East or US West, be aware it ingests everything in the buckets you tell it to, and there is a cost associated with that. It can be quite high. So make sure you've got a smart bucketing strategy there. But we've all seen massive headlines over the last 2 years of people leaving buckets. I will say, actually, let me correct that wording, of people making buckets public and then having data exposed. Because by default, when you create a bucket, it's locked down. So anytime you see a media alert that says, hey, this company got breached by an open S3 bucket, they at some point made a mistake and opened that bucket up. They start locked down. Macy can help you make sure they stay locked down, but there is that ingest cost. So it's looking continuously. When it finds something, it generates an alert. The alert, I wish they just called it a finding, but it's an alert, gives you the same kind of thing, as well as the number of occurrences. So if it found credit card information or health card information, it will pop that up and say, hey, I found 312 instances of health card information in this object or in this bucket. Valuable stuff, runs constantly. AWS WAF, this is running on the edge. This is our web application firewall. It has what's called a WACL, which is my favorite acronym. It is an access control list. It's basically just a set of rules, right? So it's giving you a set of rules. It's running continuously on all web traffic coming in. And then it's going to generate alerts. Now, most of the time, these alerts are, hey, I already took care of it, because it's telling you what rule fired within what rule group. You can write your own rules within AWS WAF. You can grab some from the AWS Labs GitHub. So github.com/AWS Labs has a set of great rules. Or there's a partner marketplace where you can get some from trusted security providers where they've already written and maintained the rules for you. So lots of flexibility here in the WAF as far as the rule set. But for our purposes today, they're generating alerts when it finds something or when it stops something, which is absolutely critical. So what we're going to do is look how we can kind of link these together. And we remember there's 3 detect and a prevent service. So what we're going to see is starting from the right, we're going to get an alert from WAF saying that it's getting a higher than normal set of rule triggers. So let's say somebody's trying a SQL injection attack. Now WAF's stopping it, which is great, right? But because somebody's trying, we know that's a threat. We know we need to respond to that. So what we're going to do is take some logical steps, right? We're not just going to freak out, though that's normally step 1 for a lot of security folks. Swallow that freak out, and we're going to take some logical steps to be a little more aware of what's going on in our environment. So what we're going to do is we're going to lower the level of severity of the alerts that we're looking at in guard duty and in Macy. So instead of just looking at critical alerts, we're going to maybe go down to medium level alerts. The reason being is that we know somebody's trying to get in, right? Normally it wouldn't be worth our time to look at medium level severity alerts because we know we've got other mitigating controls in place. Here we're going to say, well, wait a minute, somebody's knocking on the door. We might as well make sure that all the windows are locked as well, right? And we're also going to take an additional step. We're going to ask for inspector to run an assessment. Because if somebody is trying to launch something like a SQL injection attack, maybe there's a vulnerability that got announced. That happens all the time. Every time you see a new vulnerability released, a new CVE released in the public, we see globally a massive spike in attempts of people trying to exploit that. Right? It's this rush between us as good guys trying to patch it and cyber criminals trying to exploit it. So it makes sense to run an assessment to say, hey, wait a minute, do I have a new version of software that I haven't deployed yet? Is there an additional vulnerability here? But we have a trigger, and then we have logical responses back across them. Another similar concept. We're going to go the other way, though. We're going to start with an Amazon inspector inspection. So let's say we're rolling out a new version of our application, and before we do that, we run an assessment. We say, well, wait a minute, before this hits production, let's make sure that we don't have an older version of software running that's vulnerable to something that we want to address. It finds something, so what we're going to do is we're going to actually add a rule to WAF this time. So we're doing the exact opposite. Instead of WAF seeing a spike in attempts, we're going to say, we know we have a vulnerability, let's mitigate it out on the AWS edge. We're going to add that custom rule in, whether we do it or we get an update from a partner in the marketplace. Then we're going to do the exact same thing. We're going to monitor lower severity alerts in guard duty. And for Macy, we're going to add an alert that's related to the data that server is actually protecting. So it's a very simple setup of steps, right? And you can automate this entire thing, or you can go through it manually. But all the pieces are here at very low cost or free, available right out of the gate from AWS, right? These are all to help us address our responsibilities in the shared responsibility model, right? The inspector is purely dedicated to us in EC2 trying to secure our operating systems and our applications. That's our responsibility, but AWS has created a service, in this case Amazon Inspector, to try to help us meet our responsibilities. Okay? And that's happening time and time again with guard duty helping us protect our account. It's our responsibility to lock down our account. Guard duty can help us do that. Macy with our buckets that start locked down helps us make sure that we don't put and expose sensitive information in those buckets. And then WAF helps us keep attacks as far away as possible. So it's a great set of tools that help us. So let's kind of bring this back together. Let's wrap this up a little bit. Absolutely critical to start changing how you're thinking about security. So let me ask as a bit of a refresher, but just in case, how many folks in this room are on the security team? Right? Okay, so a small percentage. So for those of you who are not on the security team, and security folks, maybe earmuffs for a second, because this might get nasty. For those of you who are not on the security team, how often do you deal with the security team before there's a problem, before you know what hits the fan? Do you see them every day? No? Do you see them once a week? Do you talk to them Friday before Monday's deployment? Probably, right? The way we've set up the organizations is hampering the effectiveness of security. Because I guarantee that all the folks who were polite enough to earmuffs on the security team want to work earlier because they can be more effective earlier in the process. If you bring them in at the last minute, they are handcuffed. You can't do much, right? Earlier, we know it's cheaper. We saw that slide where we're paying 30x the cost as opposed to when we plan. So remember, this shared responsibility model is the core of how everything in the AWS Cloud works. The advantage here means that we can take our limited resources and focus in smaller areas. Okay? When we start to creep into EC2, which is where most of us will start, working in and just getting servers in the cloud, right? We're getting EC2 instances, which are servers in the cloud. You don't have to worry about the virtualization layer, right? You may have never heard of the term Nitro. That's the virtualization layer that AWS has created and runs underneath that EC2 instance. You don't have to worry about it. You have to verify that they're locking that down, same with the infrastructure and the physical side. You can do that through AWS Artifact, or you can do that through just looking at the compliance page of all the logos, because they have to maintain a top global level of security, right? The cloud is all about reputation. AWS has one of the best reputations in the business, and they've earned that because they continue to provide world-class security. The great thing is, for us as customers, we just have to verify that they're doing their job, and then we can focus on fewer areas. In this case, when we go to an EC2 instance, we're going to focus on the OS. It's hard enough to lock these things down. If we can delegate other responsibilities out, that's a win. So we can do that, and you need to work with your security teams to make sure those configurations are set. There are tons of great guidance in the Well Architected Framework, in the AWS Launchpad that just launched this fall, helping set up multiple organizational accounts, AWS org structure, which will help you set up standardized accounts in the cloud to mandate how you do security at each of these levels or how you do baseline configurations. As a business unit, you want to be pushing as far right as you can, as many managed services as you can, because that means you have less and less security and operational areas to focus on. You're delegating more of that out to AWS. Yes, you have to verify more, but verifying is such a tiny fraction of the actual work that needs to be done. As you start building, or before you start building, and as you continue to build, make sure everybody on your team has read and internalized the Well-Architected Framework. There's literally a decade plus of learning in these set of documents. Okay? There's no need to make all the common mistakes, and the number one common mistake is taking exactly what you have in your data center today and moving it over with no plan to change it as it sits in the cloud. Forklifting something is a great first step, as long as you make sure that second step is modernizing that deployment to take advantage of the features and functionalities, things as basic as auto-scaling, that sit in the cloud. The framework will help you do that. There's also a great set of videos underneath the Well-Architected Framework site on AWS solutions engineers as well as customers, talking through how they built things and why they built them, including some great migration videos. And you got to remember, you need to automate as much as possible, not just on a security side, but in general, but the security wins are huge. Ironically, the first step to automating, especially in a new environment, is by starting manually. So taking those steps manually to see what needs to change where and what makes sense for your risk tolerance, what makes sense for your operational environment. Once you've determined that risk tolerance, then you want to shove everything into Lambda. Lambda is your operational automation heart. It is the center of everything you want to do. And the reason being is it's infrastructure you don't need to monitor, right? So one of the biggest challenges with creating a monitoring system in your network is that you then have another system that you have to monitor. Because if the monitoring system goes down, then you're not monitoring your primary network. Lambda is a full abstract level, SaaS level service. You give it code, it executes. You can check on the health of that execution, but it's far less overhead operationally than trying to stand up your own automation system, right? 3 key steps if you're starting to automate, as you continue to automate, so that you completely understand it. The huge advantage here is not only doing less work, not only getting the systems behind you to do less work, but you're also getting automation in your playbook. So as you write each of these automations, you should be treating them as code. It's infrastructure as code. It's your operational playbook as code. Check it into a repository to version control, because then you know everything that's running in production is this version, right? Or version X -1 or +1, whatever the case may be. But you can track what's actually going on, as opposed to that, well, I think this is what's happening, right? We all have had those spreadsheets or those Word documents or a wiki somewhere that here are the steps you should take in the event of an incident. Automate it, because then you know the steps are always accurate, but better yet, you don't need to take them, you just need to kick it off. So that's how you, high-level overview of how security works in the AWS Cloud, how you can start to shift your thinking to modernize that. Yes, there's a huge amount of cultural challenges. I don't think anyone's going to do themselves a service by ignoring that. Your organization is set up to counter a lot of these advantages. You can break that down by doing something as simple as having coffee with the security folks in the room. Security folks calling the app folks and saying, hey, we're going to go for lunch. Breaking down those barriers, because the culture change is going to let you start to take advantage of the technical power that's available to you now in this new environment. So I'll be around a little bit for questions here and then out in the hall. Thank you very much for taking the time. I appreciate it. Please fill in the feedback throughout the day. AWS uses that to tailor future events and to make sure that you're getting the right content that you need. If you need to hit me up online, at MarkNCA, and Trend Micro's out in the hall if you want to talk to them about their specific solutions. Thank you very much.